In this video, we're going to use a very special formula to transpose every X amount of rows. In our case, 5. X, of course, being the variable here, so we can pick any number we need. So let me give you a scenario. You run a query to pull data, and what you get are multiple rows of data for the same individual. And we've all been there anytime we've ever ran data. Particularly when I'm working in sites like TVIS and iNow reports, I get this a lot. Now, the thing about it is when I get this, reality is what I want, of course, is not 3 columns with 5 rows. What I want, of course, is 1 row and 5 columns. I want this here to look more like copy, transpose, to look like that. 1 for each person. That's what we want this to look like. Now, we could do this and do this exactly like I just did. The problem is when we start talking about 500 and 600 students, each with 5 rows, well, if you think 500 students by 5 rows, that's 2,500 rows of data. That is a lot of copy and paste, and that's not what we want to do. Rather, what we want to do is we want to have a formula to do it for us. And that's exactly what we're going to do. So remember, transpose is to take the vertical and paste to the horizontal, or vice versa. We can go either direction with this. And I found this formula at mrexcel.com, and I'll put a link to it in the blog. It's a fantastic website. This particular formula was posted by a user named Dominic, and like I said, he just became my Yoda because this formula is pure genius. And it's based on the use of equals index, and that's what I'm going to show you first. So equals index. The way equals index works is it scans or it references an array or a range, and then it looks for a specific row and column number and returns that value. So in our case, we want to index our table. Now this table name is TVIS. So we're going to index the TVIS. Now, very important to notice, it did not include row 1. In other words, any row we choose, we have to subtract 1. So row 17, column 3, it says 57.1. That's what we're aiming for. So we'd have our array. Now our row number in this case is then going to be 16, and our column will be 3. Now if we did that correctly, it should return 57.1, and that's exactly what it does. So the formula we're going to use is entirely based on that original concept. Now the first step for us, though, is we're going to take these names here, and you can imagine once we get a whole enormous amount of data in here with all the students, and what we're going to do is we're going to paste it, and then we're going to remove the duplicates, and then we're going to add it into the table. I do not want to put this in column D to start. If I put it in column D to start, it automatically becomes a part of the table, which means when I remove the duplicates, it removes all of the data from A, B, and C except for 10 rows, and that's not what I want. So I'm going to paste, and then I'm going to remove the duplicates on this. Now right away, do you notice it dropped that one because of this my data has headers? I'm going to uncheck that so that it makes sure it includes this one. And then I'm going to hit OK. So 40 duplicate values were found, 10 remain, which is exactly what I want. So here's my 10 students. So I'm going to go to column D. I'm going to type in students. Then I'm going to take this, and I'm going to put it right there. So now we have our students. The next thing we're going to do is we're going to copy, and we're actually going to transpose those projections to here. Now we have the table that we want. This is what I want our table to look like. I want 1 row for each student. I want 5 columns for each piece of projection data. That's how I want to do this. So the formula is automatically going to go every 5 rows, and it's going to set that for us. So when we come here, we can equals index. Now the first step here is telling it, of course, the array. What are we indexing? Well, we're going to do absolute value of C2. So remember, when we do absolutes, we do $sign. So $C, $2 gives us the absolute. So we're saying at that point start, and you're going to go until you get to $C, $51, which is the bottom of our table. So that's what's being indexed. Now the next thing we're going to do is we're going to say rows. Now rows in this case is going to be where we're going to move our data from the index 2. So our rows is going to be E2. So we're going to say E $2. We're always going to start at E2. And then we're going to go E2. Now you'll notice what that means. So what we're saying is index column C 2 to 51, and then rows E2, which is where we're going to start, and then you'll notice it's colon E2. So it's that location, E, absolute location, but then as we drag over, you'll notice it will go F2, F, G2, H2, I2. It will work across. It will always start at E though. If we drag it down, it's always going to start in that location where we want it, and then as we go over, it'll update the other columns. Now the next step here is to tell it what we need it to do. So we're going to say times 5 minus 5. That's the number of rows we're working with. So if we need 8, then we change the 5s to 8s. Then we're going to say plus columns. So here, what we're doing now is we're saying times 5 and then minus 5 plus columns. So we're switching this, every 5 is going to switch and roll it over to this side, and it's going to put it into column data. So it's taking rows into columns. So in this case, back again, we're going to go to C2 colon C2, which is where we're starting, and then close and close, and you'll see the formula. So what it's doing is it's going to say take what's here and bring it to here. We bring it across, there we go. Here's our numbers. So these numbers here match these numbers here. Then all we have to do is drag it down. And now we have all of the data right here that we had in this. So this long mess of junk, you can see it right here. It all fits right there. So now what we can do, we can come in here and we can copy, paste special so that we're left with the values, and then we can delete, and there's our table, looking exactly the way we want it to look. We went from having all of those rows to having one row per student and all of the column data, and this is what we want it to look like. So this formula here that Dominic wrote will do that exactly. Remember, of course, to change the 5s to whatever number you need to do it. The index portion right here, that is, of course, what you're scanning, the array. The rows is going to be where you're going to start, and this is cell specific. So you're going to start in this particular cell. Then how many cells, how many rows are you going to go over, how many columns? And then the column, of course, comes back to this first one. In other words, we're going to scan this to put it to here, starting at E2. It's going to go over 5 columns, and the data is going to start with C2 and then work over from there, and you'll see what it does. So that is how to transpose every variable amount of rows. It's a really, really awesome and massively helpful formula when you start downloading a ton of data.